this one is pop quiz 5, which is related to graphs, motion under gravity, with and without air resistance. Starting with the first question, multiple choice question. An object is rising vertically at a constant speed. Remember one thing, whenever object is either moving with a constant speed, so there should be no resultant force, or the resultant force should be zero. Means when we find the result of the forces acting on the object, when object is moving at a constant speed or object is at rest, so there should be no resultant force acting on the object. So when we check the option, if option A, 1 Newton and 2 Newton are acting upward, so what is the total upward force? The total upward force is 3 Newton. And total downward force is also 3 Newton. So there is no resultant force. That is one thing. But the second thing is, if you see the question, they mentioned the object is rising vertically. So object is going up. So if an object is going up, what should be the direction of the drag or the force which opposes the motion? The drag always, like the drag force, or is a resistive force. It is always opposite to direction of the motion. So if object is rising up, the direction of the drag should be downward, like, because drag is always to oppose the motion. If object is moving towards right, the drag should be toward left. So in this option A, there is no resultant force, but the what is the mistake here? The direction of the drag is incorrect. Because the object is going up, as they mentioned here, the object is rising vertically. So as the object is going up, the drag should always oppose the motion. So drag should be downward in this case. That's why A cannot be an answer. When we check B again, even without calculation, there is a resultant force in B, like 3 and 2, that is 5 Newton upward and 1 Newton downward. So there will be a resultant force of 4 Newton. So it won't be move at a constant speed. And another mistake in this one, that there is a drag which is acting upward. So drag should always oppose the motion. So if object is going up, the drag should be down. If object is going down, the drag should be up. When we check option C, the direction of a drag is correct, but when we check option C, the upward force 2 Newton and 1 and 3, 4 Newton. So means there will be a resultant force of 2 Newton downward. So this object does not move with a constant speed. Why? Because there is a resultant force. And when we check option D, a 3 Newton upward, 1 and 2. So what is the resultant force? The resultant force is 0. So if a resultant force is 0 and the direction of a drag is also correct, that object was moving up, the direction of the motion is up, and the drag is opposite, which is downward. So this object will move at or rise with a constant speed. Is it clear? This question? Why D is the right answer? So remember, drag should always oppose the motion. And the second thing, that because the object is moving at a constant speed, so there should be no resultant force act on the object. The next one, a tennis ball fall from upstairs window of a house. What can be said about the acceleration if the air resistance is ignored? When air resistance is ignored, the acceleration is always equals to the value of a gravity of that planet, or acceleration will always be constant. For falling object without air resistance, their acceleration will always be constant. So it depends on density. No, acceleration does not depend on density, it depends on gravity. Like stronger gravity, greater acceleration of an object. It depends on the mass. No, it does not depend on the mass. It depends on the gravity of it. It increases as the ball fall. No, look, falling object acceleration, either it will be constant without air resistance, and with air resistance, it will decrease and then it become 0. Like when we sketch a graph for like we sketch a speed time graph for objects which are falling without air resistance, so it will always be a straight line which shows a constant expression. And with air resistance for falling object, when we sketch a speed time graph, so it will become curved and then speed will be constant, or there will be 0 expression. So for falling object, with air resistance, acceleration decrease. For falling object without air resistance, or we ignore the air resistance, acceleration will always be constant. So it stays the same as the object fall. That is true. That acceleration of a falling object does not change or remain constant. Is it clear? In question 3, a man stands next to a railway track. A train travel at a speed of 40 meter per second and it takes 2 seconds to pass the man. What is the length of a train? Means they're asking for a distance. We have the speed and we have the time. We need the distance. So we have the formula that speed equals distance divided by time. So speed of the train is 40. Distance we don't know and the time is 2. This 2 is divided. Other side will be multiplied. So 40 multiplied by 2, that will make 80 meters. So D will be the right answer. A speed time graph describes the motion. Which quantity can be used, can be calculated by the gradient, and which quantity can be calculated by area. So if we have a speed time graph, so if there's a speed time graph, an object is falling or object is moving. If we want to calculate the acceleration from a speed time graph, so what we can do, we can work out the gradient. How to work out the gradient? You can take any 2 points on the line. The first point on x-axis, that is x1. The second point on x-axis, that will be x2. The first point on y-axis is y1, and the second point on y-axis will be y2. So we work out the gradient. The gradient will be equals to y2 minus y1 over x2 minus x1. And that gradient is equivalent to what? For a speed time graph, the gradient is equivalent to acceleration of an object. But if we want to calculate the distance traveled by the object, so what we do, we calculate area under the graph. Like we draw a perpendicular and the whole area under this graph, it depends on what shape it will make. It make like a triangle or a rectangle or trapezium. So we take area of this graph, and when we calculate the area of under the graph, we get the distance traveled. So gradient of the graph for a speed time graph, what the gradient represent? Gradient represent acceleration. And what area under the graph represent? Area under the graph represent the distance traveled by the object. That's why for question 4, A is the right answer. So gradient represent acceleration, the change in speed with respect to time, and area under the graph represent the total distance traveled by the object. In question 5, a car of mass m travel along a straight horizontal road at a constant speed. So example, if there's a car and it is moving at a constant speed, like speed is not changing. We say the speed of the car, example, 120 kilometer per hour. So if speed is not changing, what we can say about the resultant force? We can say the resultant force should be 0, because when object move at a constant speed, if the force of the engine is example 300 Newton, the drag force should also be 300 Newton. So the balance forces will balance. There will be no resultant force and the car will not stop because it's a moving object. So moving object continue to move with a constant speed when the resultant force is 0. So at time t, the driver sees an obstruction in the road ahead of a car and applies the brake. Like example, maybe the road is blocked or some obstruction is there. When the driver sees, he applies the brake. This is the moment when he sees an obstruction and he applies the brake. The car does not begin to decelerate at time is equals to 0. Like the moment the driver sees the when he tried to apply the brake, the car does not decelerate instantly. What is the reason why the car does not decelerate? It is the reaction time, because what will happen, say, when you see a signal turn red, so you have to apply a brake. But when you think that you have to apply a brake, you will take your time to react to that. So what will happen, the moment the driver sees an obstruction, he will take time to react. He will take time to press the brake pad. That's why the car does not instantly, the moment the driver sees the obstruction or any blockage is there, he will take time to react. That's why the car does not decelerate at time is equals to 0 second. Like it's not like the car decelerate the moment the driver sees the obstruction. So first is what is meant by deceleration, and it's of 2 mark. So 1 mark, it is a change in speed, like decrease in speed or velocity in unit time. 1 mark is for mentioning decrease in speed or velocity, and 1 mark is for mentioning unit time. Like how every second, how much the speed changes. Then suggest one reason why the car does not begin to decelerate the moment the driver sees the obstruction, why the car does not slow down. The reason is that because the driver will take time to react, or due to reaction time of the driver, it won't instantly stop, or it won't instantly slow down, because when a driver sees an obstruction, he will take time to react. The moment, like when he's taking time to react, the brake is not applied. That's why the car will continue with a constant speed for some time. And the moment he press the brake, then the car will slow down. Is it clear? Anyone having a doubt in this part? B, that why the car does not instantly decelerate, why it takes some time to decelerate. So reason is that the driver takes time to react, and it is natural that a person driving a car, if he sees an obstruction or a road blockage, so he will take time to react, and that time is known as the reaction time. And during a reaction time, as no brakes are applied, so the car won't decelerate. Figure 1.1 is a distance time graph for a car at time t is equals to 0. State the property of a distance time graph that correspond to speed. So how we can find the speed? We can find the gradient. The gradient of a distance time graph, what it represents the speed. You can mention gradient, or you can also mention slope. The next, use figure 1.1, determine the initial speed. Like we have to determine the starting speed, means this part, where it is a straight line. So what we can do, we can take the gradient of this point, how, like this part. How we take a gradient? Like in this part, we can take any point, like this point, and the second point I'm taking this one. So first point on x-axis, that is x1. So x1 is 0. Then x2 is equals to 1. Then y1 is 0, and y2 this will be y2. Each box, 10 boxes equals to 20. So each box is 2. So y2 is equals to 22. So we'll take the gradient, which is y2 minus y1 over x2 minus x1. So y2 is how much? The y2 is 22, y1 is 0, x2 is 1, and x1 is 0. So it will be 22 divided by 1. So we get as 22 meter per second. That's how we work out this, because they ask for initial speed, starting speed. That's why we take the initial part of the graph to work out. Say, for example, the same question was there. Instead of saying initial speed, they say calculate the speed at time is equals to 2 seconds. So what we'll do in that case, when time is equals to 2 seconds, the graph, it's not a straight line, it become a curve. So when it become a curve, then you cannot take points on the curve, you have to draw a tangent. Length of a tangent, it's up to you. You can draw a longer or a shorter tangent, but you have to draw a tangent. And then take 2 points of the tangent The first point of a tangent will be x1. The second point will be x2. Then this will be y1 and then y2. So this will be x1, x2, y1 and y2. And we find the gradient, which is y2 minus y1 over x2 minus x1. We get the speed at time is equals to 2 seconds. If the question was time is equals to 2. Same thing if they say calculate the speed at time is equals to 3 seconds. So we will mark a point where time is equals to 3 seconds. And again, we will draw a tangent because it's a curve. So whenever it's a curve, we draw a tangent. But initial speed, when we calculate here initial speed, it was a straight line for that part. So we just take 2 points on a straight line and find the gradient of that section. And if the same question was there, calculate an average speed. So to get an average speed is the total distance divided by total time for the journey. The answer for these type of questions, there is always a range is there. For these type of question, there is no fixed answer. Even when you determine the initial speed, the range of answer was from 20 to 25. This was a range of answer here. Like from 20 to 24, not 25, it was 24. So this was a range of answer. So whenever you're drawing a tangent, length of tangent is up to you. Longer tangent, more you will get a likely you will get a right like closer to the right answer. And it's about like 3 centimeter or 5 centimeter tangent if you draw, that's also fine. So this was a pop quiz 5, which was related to motion, graphs,